So good morning to all. Welcome to my lecture 2. Myself in Rajan, Assistant Professor from Department of Agricultural Engineering at Sri Shanma College of Engineering and Technology. So in this lecture 2, today we're going to see what is the soil profile. In the soil profile topic, we're going to see different horizons presented in the soil profile. We're going to see that each horizons elaborately. Then we're going to see the overview of the physical properties of the soil. So physical properties of the soils are classified into two, that are major and the secondary properties. In that major properties like soil porosity, soil density, soil structure and structure we're going to see in that in today's lecture. Then in secondary property, we're going to see soil color, temperature, soil consistency and probability, like that we're going to see in that like in today's lecture. Then finally we're going to see how three properties of the soils are interacting and how they making impact on our soil environment. Okay, we can start the session. We can move to next slide. Yes, soil profile. A soil profile is essentially a vertical cross section of the soil that extends from the ground surface all the way down to the underlying bedrock. This cross section is not uniform, it is made up of distinct layers called horizons. Understanding the soil profile is crucial because it provides a detailed view of a soil structure. By examining it, you can understand key characteristics like its fertility, drainage, and suitability for activities such as agriculture or construction. Yes, each horizons or layers differed based on their properties like texture, color, thickness, and chemical composition due to their formation process. So in next slide, we're going to see each layer and horizons detailedly we can see in next slide. Uh, uh, Main layers of the soil profile. So here I tabulated the different horizon along with their properties with pictorial representation I given here on right side. For your easy understanding, you can see how each layers are located under the soil profile. So first one is the O horizon. Horizon is called as organic or humus layer because of its organic content, enormous organic content present in horizon O. That's why it's called as organic or humus layer. So horizon O, it's a very top layer resting on the mineral soil. So it is dominated by organic material. It consists of dead plant and animal matter in various stages of decomposition. So here, it provides essential nutrients to the soil as it decomposes and reduces the impact of raindrops, preventing surface sealing and erosion. So it has high capacity to hold water. Then O horizon usually in dark brown or black color due to the high carbon content. It is often thin or absent in cultivated fields or grasslands due to mixing and rapid decomposition. Then the second one is the horizon. It is located beneath the O horizon. The A horizon is called topsoil. It is directly beneath the O horizon or at the surface in its absence. So it is a mixture of mineral matter like sand, silt, and clay, and abundant in humified organic matter, humus. So humus content is highly seen in this layer. This is where most of the biological activities takes place. So the horizon A layer is the primary zone for seed germination and the bulk of plant root growth. So it holds the highest concentration of plant available nutrients and retains water effectively due to the mixed humus. Then the horizon A is a home to the majority of soil organisms like earthworms, insects, fungi, and bacteria because of its properties. Then it is generally in darkest mineral horizon, darkest color, and it is called as darkest mineral horizon. And typically it has a granular structure. So this layer most susceptible to erosion. Then third one is the E horizon. The horizon E is called as the elevation or leaching layer. It is located below the A horizon and above the B horizon. This horizon is commonly seen in forested and older places like are well developed soils places. Then this horizon E composed of sand and silt particles. It is depleted of or leached of clay iron, aluminum oxides, and organic matter. So the elevation, this means washout or leaching. So that's why this layer is called as the elevation or leaching layer. So what leaching means water moving downward dissolved in down water moves moving downward in dissolved state and carries away minerals and colloids from this layer. So the characteristics of the E horizon typically is lighter in color than the A and B horizons because the dark organic matter and colored mineral oxides like iron have been removed in this layer due to the leaching process. The fourth one is the horizon B, shortly called as the subsoil. Another name for B horizon is subsoil. It is located below the A horizon or E horizon. So the characteristic it characterized by elevation, which is the term washing in or accumulation of material leached from the horizons above. So you can see in the horizon E, leaching action is taken. In the horizon B, accumulation action has taken. So from the leaching material from horizon E is accumulated at the horizon B. So it is rich in accumulated materials like silicate clay, iron and aluminum oxides and carbonates. So silicate clays gives its blacky or prismatic structure to this B horizon soils, and iron and aluminum oxides making it redder or yellower color to the soil. Then carbonates in this B horizon making it as the drier climate. Then it acts as a storage zone for water and essential minerals, which deep-rooted plant can access. Then this horizon often denser and has a more defined soil structure. Example, black hair prismatic. Then when a, compared to the A horizon, so it is generally in denser and harder and lighter in color than the A horizon. The fifth one is the C horizon. It is called parent material or like regolith. So it located below the B horizon. It consists of unconsolidated, partially weathered geological material like regolith. That means regolith. So the regolith means unconsolidated, partially weathered geological material. So it is almost like parent and almost partially like new soil form. That is called regolith. So this material may or may not be the original parent rock from which the upper layer formed. So sea horizon provides a geochemical foundation for the soil above, influencing the mineralogy and texture of the upper horizon. Then it has a very little organic matter and minimal biological activity when compared with other horizons. Then it shows little evidence of soil forming processes like here I in previous lecture I given the another term for forming process, that is pedogenesis, that is occurring in this layer and often contains large rock fragments have been seen in this layer. Then final one is the R horizon. It is called bedrock. It is the base of the soil profile. You can see at the last of this picture, you can see right side, R horizon is located below and underground. You can see. it is a continuous mass of hard and unweathered bedrock, or we can call it as the solid rock. It consists of solid rock. Examples include granite, basalt, or or unconsolidated. Sorry. It For example, for our bedrock is our horizon, or granite, basalt, or consolidated limestones are presented in this horizon. So it is not soil, but it presents may marks the depth limit of the soil profile. So over geological time, weathering of the R horizon can contribute to the sea horizon above it. So then R horizon impenetrable, R horizon is impenetrable to the roots and water and defining the lowest boundary of the soil system. So R horizon is the at last layer who presented in the soil profile. Then I hope that you could understand that what are different horizons and its properties from the soil profile. Then we're going to see that uh, different physical properties. So as said at starting of the session, we're going to see the physical properties of the soil in this slide. I listed of different major structural properties. Uh, Yes, I already told that physical properties are classified into two groups. That are first one is the major structural properties and the secondary properties. In these slides, we're going to see the different major structural properties, and in our next slide, we're going to see the secondary properties that are major influenced by the major structural properties. The physical properties of the soil are crucial indicators of its health and functionality of the soil. These properties are often categorized into two main groups, that are major structural properties and secondary properties. The first one is major structural properties. These properties are considered the most critical because they directly affect essential processes like water and air movement through the soil, as well as root growth. The major structural properties include soil texture, soil structure, soil porosity, and soil density. So we're going to see a fundamental concepts of each physical properties. In next lecture, we're going to detailed view of each properties, because every properties will take at least 5 minutes, more than 5 minutes. So in this slide, we're going to see just a fundamental concepts of each structural properties. The first one is the soil texture. This refers to the relative proportion of the sand, silt, and clay particles in the soil. It's a fundamental property that does not change easily. So the next one is the soil structure. This describes how the individual soil particles like sand, silt, and clay are aggregated or clumped together to form larger units called beds. So good structure is essential for drainage and aeration. Then soil porosity. This is the measure of the empty spaces. Empty spaces means here the pores. So the pores within the soil. These pores are filled with either air or water, and their size and number are vital for root respiration and water storage. The next one is the soil density. This relates to how much soil matter is packed into a given volume of soil. That example, high density, uh, that is in compacted stage, can restrict root growth and reduce the porosity. So next slide we're going to see the secondary properties. As I said, secondary properties are majorly influenced by major structural properties, which are seen in the previous slide. These properties often result from or are an indication of the primary structural properties. So the secondary properties include water consistency or water consistence, whatever we can call it as water consistency or water consistence. then permeability or infiltration rate, then soil color and soil temperature. So these are comes another secondary properties, secondary physical properties of the soil. The first one is the water consistency or water consistence. This refers to stickiness, plasticity, and resistance of the soil to deformation at various moisture contents. So it is an important consideration for tillage and construction. Then next one is the probability and infiltration rate. So first of all, we have to know that relation between the infiltration and probability. So infiltration rate is how quickly water enters to the soil surface, while permeability is the rate at which waters move through the saturated soil mass. So both are heavily influenced by texture and structure. The next one is the soil color. The color of the soil can be an indicator of its chemical composition and drainage characteristics. For example, dark color often indicate high organic matter content, while mottled or gray color can suggest poor drainage in that soil. Then fourth one is the soil temperature. This property affects seed germination and root growth and the rate of biological and chemical processes in the soil. I think you got you can you can you got understand that these properties. So in next slide we're going to see a pictorial representation of how three physical properties are interacting in the soil. Yes, we can move to the next slide. I colored the rounds to differentiate the each properties for your understanding. So that image is a Venn diagram illustrating the interconnectedness of the soil properties and how they are affected by external factors, specifically mentioning MPs, induced changes in the soil properties at the center. Here, the MP in the center part denotes the microplastics. So the interconnectedness of the soil properties, the diagram shows that the health and the function of the soils are governed by the interaction of three major categories of the properties. Uh, the properties are chemical property, physical properties, and microbiological properties. So in first, each first one is the chemical properties, but that is the left circle. Uh, these properties relate to the chemical composition and reaction occurring within the soil. The first one is the soil pH. It measures the acidity or alkalinity of the soil, which control nutrient availability. Then organic matter. It's a decomposed plant and animal materials that is a source of nutrients and improves soil structure. Then third one is the nutrients. Nutrients are essential elements required for plant growth. For example, nitrogen, phosphorus, potassium are the essential nutrients for the plant growth in agricultural activities. Then soil pollutants. So here the pollutants means toxic metals and organic pollutants. The foreign substances that can harm the plant life, microorganisms and ecosystem health that are called soil pollutants. The next one is the physical properties. Um, Top right circle, you can see in this picture, in this in this Venn diagram, that is the top right circle. Uh, These physical properties describe the structure, composition, and behavior of the solid, liquid, and gas process of the soil. So these directly affect water and air movement and root growth. First one is the aggregate, the clumping together of the soil particles into stable units called soil structure. The next one is the soil porosity. The volume of the pore spaces or holes in the soil which are filled with air and water. The next one is the bulk density. It's a measure of mass of dry soil per unit volume. Uh, indicating soil compaction. Then next one is the soil water. The amount of water held in the soil pores available for plants and other organisms. The third circle is micro indicate intimate the microbiological properties. That is at bottom right circle. You can see in this Venn diagram bottom circle. These microbiological properties relate to the living components of the soil, which includes bacteria, fungi, algae, and microfauna. So soil microbial community and diversity means the different types of and total number of organisms living in the soil. So then microbial activity. Microbial activity is the rate at which microbes perform essential ecological tasks. Example, decomposition, nitrogen fixation. The next one is the third and last one is the microbial process. It is the microbial process means the specific biochemical cycles mediated by the microorganisms. Then fourth one that is the intersection on an external influence. So these three circles intersected and influenced by the external factors. The center of the Venn diagram where all three circles overlap and highlights the common point of influence. So soils are majorly influenced by plastics nowadays, then following chemicals and other things. So mainly affected by plastics in form of microplastics. Microplastics induced changes in the soil properties. This means this suggests an external factor. Likely, microplastics is causing changes across all three property categories. So microplastics in the soil can physically disrupt structure and release or absorb chemicals and affect the microbial community and that process. So it always affect three properties that are it affects the physical property, chemical property, and microbiological property um, in different ways. So the double-headed arrows connecting in the circles emphasize that a changes in one property. You can see that double-headed arrows in that uh, circle in this Venn diagram. When two physical properties joining section, you can see that there is a double-headed arrows can be seen. So these double-headed arrows connecting the circles emphasize that a change in the one property category inevitably leads to changes in the another properties. For example, physical compaction changes. Physical property changes in form of physical compaction will lead to change in reduced aeration, affecting the microbial activity and chemical nutrient solubility. So, in changes in particular uh, property category, that leads to changes in another or another two mic properties like changes in microbial and chemical uh, properties. So this diagram underscores the principles that soil functions as a single and integrated ecosystem. Okay, we can. I think you would understand that this picture after I explained it. Okay, I think this is enough for today class. Yes, we came to wind up this session. So I hope that all of you can good understand today's topics and concepts. Uh, Thank you.